Hello, hello. Welcome to another edition of the Ai4 Healthcare webinar series. We're going to give it another minute or two as people continue to join, and then we'll get started. It's going to be a great one today. Hope everyone's warm wherever you are in this vortex of nature. I'm in New York myself. As you can see, the flowers are blooming, so we're totally fine here. It's not cold at all. All right, I'm going to give it 10 more seconds as people are still joining, and then we will begin the festivities. Five, four, three, two, one. All right, hello, welcome. My name is Michael Weiss over here at Ai4 Healthcare. I'll be your tour guide on today's little AI and healthcare walkabout. To introduce our organization, at Ai4, we organize conferences to help executives and data practitioners figure out how to adopt artificial intelligence and machine learning. If you end up liking today's webinar, make sure to check out our AI4 Healthcare conference taking place on November 11th and 12th, right here in New York City. If you want to learn more, you can head over to the website, which I'll drop into the chat in a minute or two, where you can apply to attend. And then for today's webinar, we've partnered with the Northwestern School of Professional Studies, specifically their MS in Health Analytics program. I'll drop a link into the chat for them as well. And then today, so we'll be doing a Q&A at the end. You should see in your Zoom program a Q&A button. If you just click that, enter your question, Nicholas and I will see it, and Nicholas will address them at the end. I guess if you have a question for me, go for it, but Nicholas is really your guy. And then now, without any further ado, let's get down to business. Today's webinar is called Data Science Strategies for Managing Complexity in Healthcare Operations. You heard that right, complexity. So if your healthcare operations are simple, you might want to find another webinar. Now, it is my distinct pleasure to introduce today's speaker, Nicholas Soulakis. Come on in, Nick.
Hey everybody, Nicholas Soulakis.
Hey there, Nicholas. Nice to see you again. We had a nice dry run earlier today. It went very well. You'll be glad to know. So before I hand it off to you, as I warned you about, in an attempt to humanize you as the presenter here today, if you could please share one, maybe even two fun facts about yourself with the audience.
Oh, fun facts. I have 3 kids, and a lot of times on the weekends, you can find us riding half pipe with scooters here in Highland Park, Illinois.
That is a fun fact. It also sounds like a dangerous fact, but we'll leave that at that.
Being a dad is dangerous.
All right, well, Nicholas, Godspeed. It's your webinar. I'm going to stop yapping and shut my video off. Have fun, everyone.
Great. So thanks everybody for joining today. I changed up my title slide a little bit just because we are in I'm actually in my kitchen or my dining room, I believe, because we're in the middle of a vortex here in the Chicago area. And so just to remind myself that I want to be warm, and I'm actually staring at the vast snowy wasteland out my dining room window. I wanted to I wanted to put that fire up. So my name is Nicholas Salakis. I'm at Northwestern University, Feinberg School of Medicine. I'm faculty in the Department of Preventive Medicine in the Division of Health and Biomedical Informatics. And so just to get started, just bear with me. There's a little bit of latency in how I advance the slides, so I may start talking about something you don't quite see yet. I did want to acknowledge that most of what I'm showing you today was actually funded by the National Library of Medicine on a KO1 award that just wrapped up in July. And so today we're going to talk about several things. I'm a professor of informatics, so I'm going to talk a little bit about what is informatics. And then we're going to talk about the importance of workflows and information flows and how people work together. Then we're going to do a little bit of algebra and a little bit of network analysis and just kind of give a brief overview of some of the approaches in network analysis. And then we're going to talk about how we apply it. And if we have time, we'll talk about basketball. But if you have questions, I'd rather hear from you than talk about basketball. So just a little bit about me, although you've probably read some of the bio and stuff. I'm a PhD epidemiologist. I got my degree at the University of Pittsburgh. I worked as an epidemiologist for a long time at the New York City Department of Health and Mental Hygiene as an epidemiologist, you know, doing surveillance for outbreaks, working with the community to monitor community health indicators. I said I'm an assistant professor, and of relevance today is I'm also an instructor at the Northwestern University School of Professional Studies, Master of Science in Health Analytics, where I'm developing a course called Artificial Intelligence and Practical Machine Learning. And so today is really a lecture zero for that course. I wanted to kind of give a feel for what that course would be like. And of course, some of the, just in general, some of the courses at the Health Analytics program. So this is really lecture zero. These are sort of some foundational things that you might want to consider before, you know, sort of precursors to artificial intelligence and machine learning. But just a little bit about the program. If you want to learn more, there's a URL on the screen. It's a great program. Students learn to improve healthcare delivery using data analytics. There's faculty both from the Feinberg School of Medicine as well as Northwestern Memorial Healthcare. It's neither clinical nor quantitative, depending on what your strength is. The program can be tailored to you. Of course, this is, you know, it's timely given that this is where a lot of the jobs are growing. And the thing's entirely online. So you could be sitting at your dining room table like I am today, taking a course, which is very convenient. So if you just want to check it out, it's the Master of Science in Health Analytics at our School of Professional Studies. So without further ado, just give me a second here. I just wanted to talk a little bit about informatics because not everyone necessarily understands what informatics is. And this is a cartoon from one of my mentors, Charles Friedman. And essentially how Chuck described the fundamental theorem of biomedical informatics is that a human being working in concert with an information resource should be better than a human being alone. And really, it's a very simple cartoon, but I think it reveals some things. Number one, this plus sign here is sort of what I refer to as informatics methods. How do we actually deliver the information to the human being? And of course, this is a very old computer because the article is from 2009, but I think you understand this computer can stand for data, technology, hardware, information, in general. And so this plus sign really is trying to understand informatics methods, methods of delivery, methods of human-computer interaction. How do we actually work with this information and get the information to the individual? And then this greater than sign here is really the research question of informatics. Is this person better off or not, right? And that's what I'm always trying to understand is, is this person better off or not? Because let's just face it, we can deliver a lot of information to a human being in a lot of different circumstances. They are not necessarily better off because of it. There's information overload, there's inaccuracy, there's biases, there's all sorts of things. There's timeliness. And so we really do need to understand, is the person better off or not? And so that's really the domain of informatics research. And so my particular domain of informatics research is population health and public health. And the tools I develop are geared towards population health scientists and and meeting their information needs, and then asking the question, are they able to do population health better now that we've delivered that information? And given that artificial intelligence is in the title, I think that the second cartoon is also very relevant. And that's that we are not a science trying to build computers that are smarter than people or eschew people from the process entirely. This is not informatics. There's a lot of fields, valuable fields, in fact, that do this, but informatics is really about human beings working in concert with information and technology. So, like I said, this is really class 0 or lecture 0 of a much longer class. And I started this way because I think it's really important to understand in any healthcare setting what is really going on. And so I'm going to kind of step you through over the next 4 or 5 slides the process of how I work with the clinical department to really get to the starting point of good informatics work, which is essentially what is the question we're asking and how are we going to define success. So it's really common that, being an informatics guy, and you yourselves out there are probably the data guy or the data person in your institution, and people know to come and find you when they have problems. And a lot of times what I'll get is something that looks like this. So this is NMH to NMH heart failure readmissions. And what you're looking at here, I know this is small, but here's the daily counts of readmissions. You can see from 0 to 6 readmissions a day. And you can see here, down here is the rolling 30-day readmission percentage, which fluctuates around 20% on any given time. And a lot of times people will come to me and they'll say, hey, Nick, we've been trying to move the dial on readmissions, and we really are stuck here. We'd like to try something new. And so I think this is very common because people will look at dashboards and they'll say, hey, I'm looking at a number here over time, and I can't really get it to move. But this is really an oversimplification of what's really going on, because a readmission is the result of a very complex healthcare process. And so my question is usually, well, what's going on here? What is leading to this readmission? And so we usually sit down and we try and understand the process of healthcare delivery that leads to the outcome that the person cares about. They've already said, hey, I care about readmissions, or I care about patient satisfaction, or I care about a safety event. So they've defined their outcome. And so I'll say, hey, how do we get to that outcome? And a lot of times they'll actually say, I don't know. Or they'll say, well, it's complicated. And the first thing I try to do is work with the person to communicate to them. They know a lot more about the process than they think. If they're the medical director or an operations manager or a department chief, what I'll usually do is I'll say, hey, take 15 minutes at lunchtime, and I just want you out of your head, don't use any resources, just draw out the process. Just go ahead, pen and paper, and you can see here, this is actually inpatient chemotherapy. And the medical director who, she's talking to an informatics guy. She knows I'm going to get to an informatics solution. And she was thinking, well, I'm going to have to get very high tech about this. But once I said, no, just draw it out, circles and arrows on a piece of paper, she was able to essentially to summarize inpatient chemotherapy in her clinical unit in 2 pieces of paper, right? And I'll just tell you that I do this with almost everyone I work with. And these 2 pieces of paper can usually get us through a month's worth of work. Just talking about, and I literally just put this on my desk. I take a picture of it. I put it in a deck. I print it out. We talk about it. And really, I can't really overestimate the value of just first of all, engaging the clinical partner and engaging that unit leader in building out the process, not hitting them with technology, not giving them something they don't understand, not talking in jargon that they couldn't possibly use, but really communicating to them, hey, you are actually the expert here. You know more about this than anyone. And eventually they'll get excited, and slowly but surely it'll start to become more and more systematic. They'll start to add actors. They'll start to be more specific about their activities. They'll start to understand that there's gray areas and decision points. But really what we get to is, a more complicated, or at least a more detailed version of the process. And then what we start to do.
Nicholas, one quick sec. Sorry, someone just wrote in the screen is stuck on the what is informatics slide.
Is that true?
It looks fine for me. I saw all that. But what does it look like on your screen?
It looks like the screenshots capture actual activity.
Okay, then we have two. Okay, so that was probably just that person's. Okay, I think we're good. Sorry.
If people are having a problem, just write in and let Michael know.
Two more people wrote in that it looks fine. Okay, we're good. Thanks, everyone.
I'll try and be extra descriptive in my detail in my description of the slides.
Sorry to interrupt.
So what we're looking at here is, once the person starts to spec out what the process is, then I'll actually go and I tell my students the two most powerful tools in informatics are listening to people and observing processes live. And so what you're looking at here is when I actually go to the clinical unit, I'll usually sit with someone and I'll say, can you use the EMR to guide a patient through this process? And what I'm really trying to understand is, for some reason, I feel like we skipped a slide, but we totally did skip a slide. Just give me 1 second here. There we go. Yes, we didn't magically get the screenshots. There we go. Eventually, what we do is we get to a very detailed EHR workflow where after sitting at the elbow with them and trying to understand exactly what is happening in the EMR and mapping it to the steps in their process and really looking at the exact data points, now we have things like it's a form. We know exactly what that form does. We know the time of the form, we know the name and the position, and more importantly, we know how this all flows into the data warehouse in the back end so that then I can retrieve the data. So we've done two things here. We've demystified the process and we've mapped the data to the data warehouse. And eventually, all of these numbers and all of these things roll into, sorry guys, my slides are behaving a little weird too, so sorry if this is a little bit choppy, but eventually we end up with the global process here, where you can see here the steps are all numbered. There's an actor, there's a specific activity. These numbers in red correspond to the to where we've mapped data. And 1 second here. And so let's just dive into this just a little bit further. So specifically, I've done some work in discharge planning. And so, someone this is a grand process. And eventually what will happen is they'll realize that they just have described way too much process for us to actually try and fix. And so, for instance, in this project, we specifically zoomed in on discharge planning. And you can see, even though discharge planning is only one part of a cardiology encounter, you can still see there's a lot of steps here. We have cardiac behavioral medicine, nutritional therapy assessments, occupational therapy assessments. We've got attendings doing things, nurses doing things. It's still a fairly complicated process. And so I just wanted to point out to you guys that in most of the slides a lot of the slides, you'll see down here there's references. And those are actually to published papers. So some of this discharge planning activity work, you can just Google Cricky et al. JAMIA 2016, and you'll find the paper. So I don't give a lot of calculus, and I don't really give that much results because you can find those things online. If you are turbo and you do go out and find those things online right now, and you want to ask me about a result, that's fine. But usually it takes a little bit too much explanation for a short talk to get into all the work that goes into some of these numbers. But for the most part, what I'm really trying to share with you is the importance of mapping out the process. And so once you've done all that, you sort of get to your first work product. And it's really funny because I know that people come to me looking for analysis and really interesting data mining and all these things. And really the first 2 months of probably what we did was produce this document, the business as usual document. And it really states, what it really does is it states the problem. It reminds them of the outcome that they're interested in. It reminds them of the work we've done in defining the process and mapping the data to the various screens. And it really gives them a roadmap for understanding their process and their data so that then we can go ahead and get started. And furthermore, this is a really good place just institutionally, organizationally, this is a really good time to have a meeting with a bigger group, because by this point you've probably only been working with a couple people or a few people that are intimate with the process. This is a really good time to open it up to the wider, audience within the organization or the unit, and really start to have the conversation about improvement. This is also where you get more senior level buy-in, like, hey, they're not just, these aren't just ideas. There's a lot of good work here. We've gathered facts. We've gathered a lot of facts about our process. And I think that we have a good foundation to do this work. So I like to tell people, that a lot of what we're going to do actually for the first couple months really is things that they're already very good at, which is producing documentation, and gathering facts. So, and then this is just a slide kind of demonstrating at this point, without doing any real machine learning or artificial intelligence, you can start to do things like pick apart your process. So this is our neurology ICU, looks at subarachnoid hemorrhage, which is bleeding in the brain. And we took apart their 11-step process once we had mapped the data. And just in our very, very initial data pool, what we were able to do is just sort of map out where the most activity occurs. And you can see that a lot of the activity occurs here in these steps 5, 6, and 7. And that in and of itself was an insight to them. So without really doing much analysis or modeling, we were able to return a lot of value. And basically we would go back at this point and we would dig further into some of these big steps that have a lot of activity and a lot of frequency to see, can we further break these down into steps that, that make sense. All right. So, sorry guys, I have to just turn the music down for a second here. All right, I guess I could have just yelled at Alexa to do it, but I'm old fashioned, I like to push buttons. Okay, so that's really like, step 0, part A. Let's understand the process, let's understand who does what, let's define success. So once we have all that, and once we've pulled the data, and once we're familiar with the process and we've refined it, now is really the time to start putting in, starting to put in some work on the network analysis. And so I call this part the SWAN methodology, but really I don't do the SWAN methodology without all that first pre-work. So the whole thing is in fact the SWAN methodology. So how are we doing on time? We're doing great. So I'm going to do a little bit of network analysis 101 just to kind of step you guys through. Some of you aren't familiar with network analysis. So I've been talking a lot about electronic health records being used for patient encounters, a lot of providers doing things on the electronic health record. So one of the things I do with that data is, now that I know who does what, I can create a network where what I'm showing you here is 2 sets of nodes. The provider nodes are at the top. The provider nodes are at the top, the patient nodes are at the bottom. And what you can see here is provider 1 had some meaningful activity on an encounter with patient A and patient B, provider 2, patient A, B, and C. And so this is called a bipartite network. that I create, or a collaboration network, some people call it, where you have providers and patients. And the edges, it is a directed network because providers provide care to patients and not vice versa. So once you've created this bipartite network of all the providers doing the activities that we scoped out in the process map for all the patients within some set time frame, you create this bipartite network. But what you can really do is project that bipartite network into a monopartite network, which is what I'm doing here. And so you can see provider 1 and provider 2 both saw patient A. So I can create a line or an edge between these two provider nodes that basically says we shared a patient. And you're essentially asking the question, did you share a patient, yes or no? If yes, put an edge between these two nodes. And you can see that provider 1 and provider 2, they shared patients. Provider 2 and provider 3, they shared patients. So I've projected my, and this is actually a subset. This doesn't even account for all 4 providers here. But you can see I've projected it into a monopartite network. And that allows you to do some interesting things. But if you look at this monopartite network, the way I explained it, I was just saying, did providers share patients or not? Well, that's interesting because sometimes you don't even really understand the structure of healthcare in your institution. You don't really understand how providers are connected in delivering the care for those outcomes. So that can be very useful, but even more useful than who works together is the question of who works together well. And so one question we like to ask is, when 2 people work together, are their outcomes better than when they work with other people? So how do we do that? So let's get a little bit more detailed. So here's a cartoon, and this is, again, this is in a publication we had a couple years ago. So let's just say you had 30 patients, and unfortunately some of those patients have a bad outcome. You can see that here in red. So 20 of those patients were seen by provider 1. 20 of those patients were seen by provider 2, with an overlapping 10 patient encounters. And what you can pretty readily tell is that provider 1 and provider 2, when they're working independently, actually have more bad outcomes than when they work together. You see here, they only had 1 out of 10 bad outcomes, whereas here it was 2 out of 10, and here it was 3 out of 10 bad outcomes. So they're actually going to have what's called their SPOR, or their shared positive outcome ratio, which is sort of the linchpin of this whole methodology. Their ratio is going to be greater than 1 because when they work together, their outcomes are better than when they work with other people. So when you ask the question, do they have more good outcomes when they work together than when they work with others? The answer is simply yes. So once you start calculating these ratios between providers, there's a lot of things you can do. A paper we have coming out now is talking about risk adjusting the outcomes. I'm not going to get into that here, but if you are interested in calculating this kind of metric for your providers, it's pretty well detailed in this circulation publication, which I show down here. So let's recap. We're very intimate with the process. We understand the outcome that the unit cares about. We know who is doing what. We found out where the data is. We went and got the data. We understand who the providers are that are inputting the data and the patients that they've seen. We've built a network with that data. And then furthermore, we've weighted the network with outcomes between the providers in the network. So again, I said this is step 0 because what we've essentially done is built a data model. We've built a data model that allows you to do a lot of different things. So I'm going to show some of those things. There's kind of an infinite amount of studies you can do with this kind of work. Just 1 second. Okay. All right. So one of the things you can do once you have the network built is you can visualize it. Okay, so let me just kind of unpack this because there's a lot going on in this visualization. But once you've weighted that entire network, one thing you can do is you can visualize the network. So what are you looking at here? This is actually about 1 year of cardiology care. This is 280 providers, 3,800 edges. And what we've done is, so I'm showing the connections, well, and it's actually a subset because the greater network is much bigger, but to denoise the network, I actually took a subset. That paper tells how to take a subset. But one of the things I've done is, so remember I talked about calculating the SPOR value between two providers. So these lines here between this node and this node, that's actually that SPOR value. And so these lines actually reflect the ratio of success between those two providers. And so, and I should say that each one of these circles is a provider in the network. And so what I've done is I've weighted the network and visualized it, and then I've used something called community detection, which is an algorithm which mutually which separates providers into mutually exclusive groups that they have an affinity for. And so there was about 5 modules that came out of this, and basically what it was showing was that the yellow group is a business as usual group. There's an oncology group because some of the patients had cancer. There's a radiology group because, of course, there's a lot of imaging. There was an ED group. But essentially, we were able to separate people into mutually exclusive groups. Now, depending on what process you're looking at, that can be very helpful because essentially, if given what I've said, you're separating groups of people into the affinity is essentially that they have shared success together. And so that can be very helpful for many things. And so, or you could use it as an investigative tool, and you could look at one particular set of providers, and you could see how, this is 21 providers and 21 relationships, and you could dig further into it. And for instance, maybe you're really interested in the relationship between these two providers. Maybe it's a nurse and a resident, maybe it's a pharmacist. If you wanted to do more deeper investigation, you could always do that as well. This is actually, we use a graph database called Neo4j. We query the graph database to pull out very, very specific subsets to do investigation of particular things that may be of interest to the unit. So kind of moving along, I mean, that's kind of complicated and it requires a graph query, but even some of this stuff does not require much technical know-how at all. I'm going to talk a little bit about a project that I did with one of our PhD students, Gail Cricky. So she actually has a social work background, not particularly technical, although she was in graduate school, so she knows her basic statistics and things. And so Gail and I, using the network that we had built, Gail was really interested in discharge planning, and so we dove into the very specifics of discharge planning, which again, you can remember this from me showing that we had mapped the entire process from the inpatient cardiology unit. So we really wanted to dive into here and understand this process. And one of the things Gail was interested in is trying to understand, does the unit actually understand the process of discharging a patient? And why is this important? I forgot to mention. This is important because if you've ever lived through a hospital accreditation from JCAHO, what you know is that there's something called a failure mode effects analysis. And essentially a hospital on an annual basis needs to step through this exercise where they engage a unit to talk about a high-risk process in their organization. And essentially what the failure mode effects analysis is getting those people around a table, stepping through the process and asking the question, what could go wrong? So this could be transplanting an organ. This could be, this could be many things. It could be feeding a patient. It could be taking a patient from one room to another. It could be practically anything. But it's essentially asking the question, what could go wrong in this process? And so a really good failure mode effects analysis has all the right people around the table so that their opinion and perspective is heard in this tabletop exercise. So if you don't have the right people around the table, it's not going to be a very good failure mode effects analysis. And so being a person that was getting a PhD in quality and safety, she knew this is something she would have to deal with and that she wanted to improve that process of FMEA. And so we stepped into discharge planning, which it's healthcare, so almost anything can be a high-risk process, and discharging a patient is no different. And she wanted to ask the question, if we had an FMEA, would we get the right people around the table? And so she actually went to the unit and talked to them about their process. And so what we have here is essentially she reimagined that process map across 4 dimensions. So when she asked the unit about the process, she asked who does this the most, what kind of people do this, who's supposed to do it, things like that. And what kind of the short story here, because we're getting a little pressed on time, is anywhere where there's color on this process is a place where the unit, even though they were very familiar with the process, did not exactly understand what was going on. So for instance, whenever they would say, well, who does this process? If you can see here where diversity is lit up, that actually means that lots and lots of kinds of people do that step in the process. And that if you only get the person that you think does that into the room for the FMEA, you're not going to have a well-rounded perspective on the process, and you might miss high priority potential failures. And that's just, and essentially that was, that requires no inference, no modeling, no statistics. That's essentially just trying to understand essentially the frequency of data versus the perspective of the unit. So we are 38 minutes into this. I've been talking kind of quick because I wanted to leave some room at the end. I'm going to just take a second here. And Michael said if there were questions, he would give me those questions.
You've gotten some in, Nicholas. I mean, the basketball example is great. Do you want to do some questions and then do the basketball example?
Sure. I actually don't have that many. So just curious whether there are differences in discharge procedures across providers for different locations, and if so, how would that affect the generalized process map that was laid out earlier? Thanks, Andre. Well, yeah, and thanks for that question, because I kind of glossed over why it's called a business as usual process. So healthcare is wild, and a lot of people have gone through their clinical training, have learned sort of the mnemonic of when you hear hoof beats, don't think zebra, think horse. But despite that, when you sit down with someone and you say, so what's the process for doing X in your institution? A lot of them still, their minds go to rare or infrequent instances. And they start to talk about exceptions. Well, when the patient looks like this, then we do that. But if they really have this, then we do that. And they kind of get lost in exceptions. And so what I ask people to do is think about what happens for 90% of the patients that come through that process. And what is it that 90% of the patients experience? Because that long tail of all those exceptions, that's pretty much going to thwart all your attempts to map this process. And so, it'll also kill your data and give you tons of noise. And so if you really want a cleaner data set, I try and encourage the people, think about 90% of the patients. So to your question about like different locations, you know, we have a lot of hospitals, for instance, at Northwestern Medicine. That starts to iron out some of those differences. And what you really should be looking for is similarities in the process, because if you do want to, you know, for instance, if I wanted to roll out an application for monitoring teamwork in a unit, I would want it to be able to impact the most amount of people as possible. So think business as usual, think 90% of the encounters, what happens for 90% of the encounters, and that'll take care of a lot of those exceptions and make your thing more generalizable. All right. Someone asked the question, someone did, rightly so, someone asked the question, what did you achieve after the analysis? Really asking, like, so what does all this get you? Like I said, this is really lecture 0, because we do go on to solve very, very specific problems in a lot of these units. Some of them might be trying to improve nurse-resident communications and trying to understand, is it all nurses? Is it some of the nurses? Is it all residents? Is it, does it depend on where they trained or how, where they are in their rotation? We start to get very, very specific, but we at least have the data and query framework to get to these subnets to analyze them. So I don't go into all that because it's kind of endless. And I can tell you, I've been working with some units for 3 years and we've never run out of questions. So so we're really getting to the point of departure of asking more and more detailed questions for those particular units. And then, so for instance, in that example, so you start to be able to separate, what you're really trying to do is get to a place where you can separate high-performing groups of providers and low-performing groups of providers. And we could get into the sociology of what is, of people being labeled high and low-performing, but essentially just what it means is that their SPOR is either high or low. And then that allows you to ask the question of the people with statistically high outcomes, what is it you do? Or the people with statistically low outcomes, what are the barriers to your success? What are the challenges you're facing? Is it resources? Is it structural? Is it regulatory? You've never been trained to do these things. And then that allows us to get further into a very, very specific QI project, which might be an in-person training. It might be a video that the chair sends out. It might be a CME module people do online. So it can be a lot of different things. So essentially, once you have the network built and you understand the process, you have a toolbox for investigating problems and getting very, very specific, and also going forward to monitoring the impact of your intervention on those things, because you do still have the network built and you'll start to understand how those spores unfold over time. So I know it's kind of complicated to fit into an hour, and we would take 10 weeks to do this in the course, and not even exactly in the AI machine learning course, but it takes about 10 weeks to understand this. So I apologize for kind of glossing over. So, all right. So I'm going to get into a little bit about basketball, because someone was saying, like, who do you actually communicate this stuff to? Better teamwork is actually just a recurring theme in healthcare, and everyone gets it. It's just that a lot of times the system of medicine which people work in does not allow for it. And if I'm doing nothing, what I'm really doing is championing the people in the process. And it does not matter where you fall in the process, whether you have a high, metric or a low metric, or you're somewhere in between. What I'm essentially saying is that these outcomes depend on people working together in a very complex process. I am here to disambiguate, to take out some of the complexity, to simplify the process, and to give you data on who is doing what. But I'm really here with you guys. And so, but I do understand that a lot of this is sociological. It's not just, and I think a lot of you guys know this, is that you just can't march into someone's office with a bunch of numbers and expect them to change. So a lot of times I go through this example of Taj Gibson. One of the things that we're working on, which is incredibly complex, is improving teammate selection. So asking the question, who is the next best person to add to a medical team? So you're in the ICU, you're 3 days in, the patient, the patient is making progress or not making progress. Who's the next best person to add to the team, given we know the composition of the existing team? So it's a really complicated question. And so a lot of times I'll talk through a basketball example. So those of you that are familiar with American basketball know that there's 5 players on the court at any given time. Those players will start the game, they'll have success or not, and at some point, someone will come off the bench to spell one of the players because they're tired or they're not doing that well. That person that comes off the bench is called the 6th man. And there's actually one of my favorite awards in the NBA, given that I do teamwork, is the 6th Man of the Year award. And in 2014, And I realize I'm talking about 2014, but this is the last time the Bulls were relevant or worth watching. So I'm going to stick with my 2014 examples. So thanks for any comments that come in that want to talk about basketball, given that comment. But anyway, so Taj Gibson in 2014, you know, the sports writers were asking, is this Taj Gibson's year to get Sixth Man of the Year? And why is that? It's because Taj Gibson is a really good basketball player. What you're looking at here is Kurt Heinrich missing a shot, Taj Gibson rebounding it and stuffing it back in the basketball. That's the kind of player he is. His teammate did not make it. He did. He cleaned up his mess a little bit, right? Kurt Heinrich trying to do something, does not do it. Taj Gibson does, fixes his mistake. He's also really good on defense. So his competition that year was Jamal Crawford. Jamal Crawford is actually, so what you're looking at here is Jamal Crawford dribbling the ball so well, in fact, that Klay Thompson falls down, and then Jamal Crawford hits the shot from distance. He's a really good ball handler. He hits a lot of three-pointers, which are better than two-pointers, of course, and he's a very flashy player. So the sports writers were trying to were asking the question, is it Taj Gibson or is it Jamal Crawford? Well, if you look at traditional statistics, keeping in mind the very first thing I showed you guys was a traditional statistic of readmissions over time. If you look at a traditional statistic, Jamal Crawford scores a lot more points than Taj Gibson in a lot less minutes and hits a lot of three-pointers. Those are great numbers. Taj Gibson, you know, rebounds, blocks, these are not flashy numbers. So Jamal Crawford is a really efficient scorer. He has big offensive numbers. Taj Gibson, defense, rebounds, creates offense for teammates, right? So in traditional statistics, it's really, it would be pretty obvious that Jamal Crawford would be the choice here. But if you take an advanced statistic like real plus minus, which essentially asks the question, when this player is on the team, does the team win or not? If you look at something like real plus minus, it separates into offensive real plus minus and defensive real plus minus. Sure, offensive real plus minus, Jamal Crawford is twice as good as Taj Gibson. You can see here 1.53 to 0.70. If you look at defensive real plus minus, Taj Gibson clearly better than Jamal Crawford. And if you look at the net effect of that, Jamal Crawford is actually a net liability to his team. However, most sports writers do not think this way. Most people look at the very easy and obvious numbers. Keeping in mind, we just spent 55 minutes talking about how to unpack the complexity that leads to those numbers, realizing how much is actually going on to get to one readmission. So if you look at Jamal Crawford being a net liability, I usually do this with a room full of people, so it's not as fun here just in my living room, but you can guess that just from these two pictures, who it was that won that year. And of course, it was not Taj Gibson, it was Jamal Crawford, because sports writers are just like the rest of us. So I tell that parable because that's really, if as a unit you start to understand that there's a lot more going on than the obvious statistics, and I'm able to unpack that for you, we're gonna do a lot of good work together. So that's kind of where I like to wrap up. We have some time for questions. Michael, you might have a couple notes for me.
Yeah, I think let's just do some more questions. I think that was awesome, Nicholas. Yeah, I see a few here.
Thanks, Michael. I've never done a webinar before, and I tell you what, just talking to my empty dining room is kind of weird. So let me get to the Q&A. All right. All right. You know, so let's see. Assuming that there will be more publications of these sort. Okay, so Teresa, assuming that there will be more publications of these sort, what is the validation appraisal process for these sorts of modeling? That's a great question. I don't know if I have a great answer, but I'm going to answer it. So what I'm actually doing, you know, you can imagine I'm a professor, I have graduate students, and we engage a lot of units. And sometimes we just get to a place where the math does not explain what's actually happening in the process. And, you know, I've done this enough, you know, and some of my graduate students have done this enough that sometimes the answer is, you know, it could just be the people. It really could just be, you know, the guy's an a-hole. or she's a champion. She's just a super person and she could lift any, she could lift any boat. And so what I do is a lot of qualitative studies these days in trying to understand what people's perspective on teamwork is and correlate that to the metrics. And so, for instance, that one of the very first hand drawing I showed you was inpatient oncology chemotherapy. We're interviewing that entire unit to try and understand how they define teamwork, how they define their role, and that brings out a lot of insights, things about autonomy, things about confidence, things about respect, interprofessional communication, a lot of passion about patients, and sort of understanding that some people are more driven by providing the absolute best patient care possible at any cost, which, that in and of itself can be fraught because we can't provide care at any cost. We do, in fact, have to run a business, and don't demonize me for saying that, but so some people will put in too much time or too much effort or too much resources, or some people are very emotional. And it's really good to hear those things because we're not automatons. We're not going to be replaced by computers. And we need to understand the emotional states of people. And, we can do all the metrics we want, but if we don't understand why these things occur, we're not going to get any better. So a lot of what I do is marry qualitative studies with quantitative studies, and that oncology paper is in process. Well, the data collection's in process. So I look to put out more of those studies. To carry on the sports, William asks me, to carry on the sports analogy, choosing members of a medical team could be the same process as portrayed in Moneyball. Is that accurate? It sure is. Moneyball medicine. Yeah, that was my little catchphrase I used to use before. That's still part of the dream, actually, is maybe we could do better scheduling. Maybe we could schedule providers. Maybe our analysis shows, and this is one of the things we're exploring in the neuro ICU, maybe pairing an experienced provider with a less experienced provider, maybe making a scheduling rule that there has to be at least one experienced kind of person X on the team. It's really interesting because usually, in that particular unit, the experienced people expect to have better schedules. Oh, I want to work during these times because it works for me. And it's a conversation about privilege. I've been here a long time. I deserve to be treated better. If you start to say, well, the numbers are showing us that outcomes are better when we have an experienced person on the team, it becomes a conversation about altruism. I'm going to be scheduled in this way because I know it's better for patients. And at the heart of it, most people want to do right by the patients. So, you want to call that Moneyball medicine, God bless you. But better scheduling is certainly part of this, and having resources available or on call in such a way that you can match people. I hate to use the word real time because everyone on this webinar knows as soon as you start to do things in real time, it makes everything more expensive. But at least being able to plan for better teamwork and things like scheduling or on-call schedules could definitely be part of this. The questions are coming in at the bottom. All right, what else do we got? What is your approach? So Ron asks, what is your approach to asking how real-world practice patterns deviate from expected for these standard processes? Have you been able to use the EHR to look at this? Oh, Ron, you fell into my nerd trap. Aside from the blink tag, which clearly labels me a nerd, I do actually have a statistical test for the SPOR. And so thanks for asking that. So basically what we do is we take the real network that we've assembled after all this process mapping and everything. And we ask the question, could these relationships occur by chance? And so we know the real outcomes of these patients. And essentially what we do is, you'll see here patient A and patient D. Patient A was readmitted, patient D was not readmitted. And essentially what we do is we reshuffle all of the outcomes of the patients. We leave the network in place, and we'll do this 1,000 times. And essentially, we'll look at the outcomes of the observed network and compare it to the simulated randomized network. And that allows us to calculate a p-value. So there is a statistical test actually for understanding the relationships between the providers. We'll leave it there because I actually forgot what the rest of the question was. Where are we? What was the rest of the question?
It was, what is your approach to understanding how real world practice patterns deviate from expected for these standard processes? And then have you been able to use the EHR to look at this?
Yeah, and so that's exactly our process. And that's actually explained in the Carson PLAS 1 paper, that exact randomization and reassortment and calculating the p-value and how observed, depart from expected is in the PLAS 1 paper. So some people are asking about the MS program, which I'm happy to talk about. The MS program is, it's a new program. It's all online. So one of the faculty directors, or the faculty director, is an excellent guy, Dr. Andrew Natick, that I work with. When I was talking about the neuro ICU work, he's done a lot. He's done a lot in intensive care and building registries for intensive care. We do a lot of work on teammate in the teamwork in the neuro ICU. So he's the faculty director, and we've got the director of our enterprise data warehouse is faculty. We've got the director of essentially health analytics for Northwestern Memorial Hospital as one of the faculty. Dr. Natick's been a medical director for years and years of that ICU. Just decades of experience amongst the faculty, a real world faculty. And essentially the dream is to have people on not necessarily real, Northwestern EMR data, but essentially sets which reflect real healthcare patterns. And those are the people really to deliver that kind of educational experience. I'm pretty excited about the program in general, and it is all online. And I can tell you that the course development process that I've stepped through with them, they really have amazing course designers that help the faculty. We're not, teaching is hard, and we're all not natural teachers, and they really work hard for us to channel what we know into our online courses. So I've done a lot of classroom teaching. I teach every quarter, but the experience I've had with the SPS staff has been excellent. So I really think that'll reflect in the program itself. I know some people just put up brochureware websites with a quiz at the end. This is anything but that. So I wouldn't teach it because I like to teach, and I would not replace in-classroom teaching with an online classroom experience if I felt like I was shortchanging this.
Cool, awesome. It looks like Hong Ji has a interesting question there. Do you see that one?
Sure. In the modeling training process in your population health, I'm going to read the question first. Do you use more zip code aggregated data, or do you use individualized data? Which one gives? Essentially Hong Ji is asking about aggregation at the zip code level. So that's GIS. That is not my particular area. I will tell you that I do a lot of, you can apply this exact same methodology to things like claims data. If you're interested in mapping out narrow networks or high value networks, and the nodes essentially become healthcare providers like doctor's offices or outpatient clinics. I will aggregate at the clinic level for some of this work. But essentially, that I still understand what the encounters are at the clinic level. So you can roll up or roll down in the approach. I don't do any particular GIS type analysis, actual geographical analysis. I'm still looking at processes and trying to pinpoint places in processes for improvement techniques.
Cool, awesome. Well, Nicholas, we're at 2 p.m. I think we're gonna call it. Let's give him a virtual round of applause.
Oh, virtual flowers are being flung at me. This is amazing.
This is an honor code. Round of applause. Thank you all for joining. Check out the chat. You can see a link to the MS program that Nicholas was talking about, as well as our AI4 Healthcare Conference in November. If you guys have any questions, you can email Nicholas right there, or you can always email us at info@ai4.io. Have an amazing week, an amazing life. See you next time.
Stay warm.
Stay warm, San Diego. Bye-bye, everyone. Thanks, Nicholas.